Welcome to The Explainer. We hear this term all the time, right? The AI black box, this mysterious place where decisions just happen. Well, today we're going to crack that thing wide open and see how a machine really thinks. So let's start with a really simple question. How does an AI see a picture of a dog? I mean, to you and me, it's a cute, furry friend. But for an AI, that picture is a huge communication problem. See, before it can see anything at all, it has to translate that image into the only language it truly understands. And what is that language? Numbers. That's it. Everything. Images, words, sounds, you name it. It all has to be broken down into the cold, hard language of mathematics before an AI can even begin to process it. And that brings us to the first big hurdle in our journey inside the machine, the translation problem. How in the world do you take our rich, messy reality and turn it into pure, clean data? Well, this really gets to the core of it. Our brains use our senses, sight, sound, and we form a concrete idea. We think, hey, that's a dog. An AI, on the other hand, takes in raw data, like the pixels in a photo, and it spits out a statistical prediction. It's not seeing a dog, it's calculating a 98% probability that the pattern of numbers matches the pattern it knows as dog. So how does that translation actually go down? It's really a two-step process that turns all that raw, meaningless data into coordinates that actually carry meaning. The very first step is something called tokenization. And honestly, the best way to think about this is with Legos. The AI takes whatever you give it, an image, a sentence, and it smashes it into the smallest possible pieces, its individual little Lego bricks. And each one of those bricks gets a number. So what are these bricks? Well, for a picture, a token is just a single pixel. For text, it's a word, or sometimes even just part of a word. For audio, it's a teeny tiny slice of sound. The AI's entire world starts out as this massive, ordered list of numerical tokens. But you know, a long list of numbers is just gibberish without any context. And that brings us to the next and kind of magical step, embeddings. This is where the AI gives every single one of those tokens a specific address, a set of coordinates that defines what it means in relation to everything else. And this is the really crucial part. These coordinates capture relationships. Concepts that are similar end up close together on this gigantic invisible map. This lets the AI do a kind of mathematical reasoning. It can literally calculate that the relationship, the vector, between man and king is almost identical to the vector between woman and queen. It's understanding, but defined entirely by math. And get this map is not in 2 or 3 dimensions like we're used to. It can have over 1,000 dimensions. The AI is seeing connections and patterns across 1,000 different axes of meaning, relationships that are completely impossible for the human brain to even visualize. Okay, so our data has been translated into these super meaningful coordinates. Now we can finally step inside the black box and take a look at the engine that does the actual thinking, the neural network. The easiest way to picture a neural network is like a factory assembly line. The raw materials, our embeddings, go into the input layer. Then they travel down the line through a series of hidden layers, and this is where all the real work happens. Each layer asks progressively smaller, more specific questions about the data, until finally the output layer assembles the final product, a decision or a prediction. And the workers on this assembly line are basically millions of tiny dials. Every single connection between neurons has a weight, which is like a volume dial that controls how important that piece of information is. And it also has a bias, which is kind of like a head start that makes a connection more or less likely to activate. So whenever you hear that an AI is learning or training, this is all that's happening. It's not some kind of conscious thought. It's just a relentless, automated process of adjusting millions of these little weight and bias dials over and over and over again until the final output is consistently right. But here's the paradox. Even though we designed the factory, and we know exactly how every single dial works, the sheer scale of it all creates a new kind of mystery. We can't always understand why the final combination of settings actually works. And this leads to a really fascinating and frankly dangerous problem in AI, something called the clever Hans effect. It's this idea that an AI can get the right answer, but for a completely wrong and sometimes totally nonsensical reason. The original clever Hans was this horse that blew people's minds by tapping out the answers to math problems. But it turned out he wasn't doing math at all.
He was just an expert at reading his owner's tiny, unconscious facial cues. Well, the AI parallel is kinda chilling. A model could get 99% accuracy identifying pneumonia in x-rays, but only because it learned to spot the watermark of the hospital that treats the sickest patients. It never saw the disease. It just found a shortcut, a cheat code.
So, if we can't just read the AI's mind, what do we do? Well, the new approach isn't about opening the box anymore. It's about building windows into it so we can actually watch what it's doing. This brand new and incredibly important field is called Explainable AI, or XAI for short. Its entire goal is to make these incredibly complex systems more transparent to us humans. One of the most powerful XAI tools out there is the heat map. So instead of just getting a yes or no from the AI, a heat map can literally show us which pixels in an image or which words in a sentence the AI was focusing on the most when it made its call. It's like seeing what the AI is highlighting with its own digital marker. And this is absolutely critical in high-stakes areas. In medicine, a doctor needs to know for sure that the AI is looking at the actual tumor, not a smudge on the scan. In finance, we have to make sure a loan wasn't denied because the AI unfairly latched onto something like a person's zip code. XAI helps us check the AI's homework. Okay, so let's boil this all down. If you're going to remember just 3 things today, make them these. 1. For an AI, our entire world gets translated into numbers, these meaningful coordinates called embeddings. 2. The thinking happens inside a neural network, which is really just a very sophisticated factory for processing those numbers. And 3, learning isn't consciousness. It's just the mechanical, relentless tuning of all the dials inside that factory. So that black box isn't completely gone. But with tools like XAI, we're building more and more windows to peek inside. And that leaves us with a final, really profound question to chew on. If an AI's comprehension comes purely from mathematical relationships, is it truly understanding the world? Or has it just created a statistically perfect yet fundamentally empty simulation of what understanding looks like?